Okay, so in 5.2 number 7, I just basically needed an example of repeated roots so I could do something. So here's my, what is this friggin' thing?
It is a
Homogeneous differential equation that happens to be second order linear.
Differential.
Damn it.
Did we say homogeneous yet?
We said homogeneous.
Differential equation.
Constant coefficient. Okay, so the way I solve these is I convert to a quadratic equation, right? By guessing y is e to the rx. So I got r squared minus 8r plus 16 is 0.
R minus 4 squared equals.
And then I notice that this is r minus 4 squared equals 0. And so that means that my two solutions are r is 4 or r is 4.
Cool.
Good question. Wait, what? So you should be guessing, right? So you'd say, all right, so y is c1 e to the 4x plus c2 e to the 4x, right?
4
plus
e
another
to
x
4x.
C2.
Yeah.
Yeah, these two things aren't linearly independent, so you do like the dumbest thing you can.
Put an x on there.
Yeah, just like maybe if I slap something simple on here, I'll just slap an x on it and see if it works. So let me check that this worked. Right, like I'm just going to take y2 as x e to the 4x and plug it in there and just verify that it worked. Okay, so what's y prime of x e to the 4x?
E to the 4x e to the 4x.
E to the 4x plus x e to the 4x times 4. Okay, and then I want y double prime, which is 4 e to the 4x. I did that part for you. You're welcome. So I just differentiated this part, right? And then that part is 4 times this stuff, right? Because you already did that work. You got plus 4 e to the 4x plus 16x e to the 4x. You're gone. I thought I lost it. So I got 8 e to the 4x plus 16x e to the 4x. So take that, jam it back in over here. So I got 16x e to the 4x plus 8 e to the 4x minus 8 times e to the 4x plus 4x e to the 4x plus 16x e to the 4x. And I'm wondering if this is 0, right? Okay, so regroup a little bit. 16x e to the 4x. Oh, those cancel. And then I got a minus 32x e to the 4x plus a 16x e to the 4x. Oh, cool. That's 0. What was the magic there?
You adding that x just out of the blue?
Yeah, somehow adding this x out of the blue seems to make things work. And I just checked that it did. What was the, so why would I think this would work in general? Basically what's up here is the product rule combined with the fact that e to the 4x solved this thing in the first place. You guys kind of with me on that? Okay. So another place you could get this is you could go sort out that other problem we did. You guys remember the other problem we did? Let me go collect it.
And buy it?
No, I did it the other day when the video camera wasn't working. Which is why I'm kind of trying to talk about it right now. It's problem number 9 in 5.1.
Hey Joe.
Yeah.
So why did we change the y from there to there?
Oh, from here to there?
Yeah.
I just was checking this part. I didn't want to check the rest.
Okay.
If you put the rest in there, it'll work too. Like that one I need. Like this one I believe will work.
Yeah.
Right. But this one I'm like, huh?
Because you just, okay.
Yeah, so I just dropped the C2 and just kept that part to check. So let me recall this other thing. So this other thing says, if you have one solution that you know of. So I'm going to think I have this one solution that I know of. Right? And I'm looking for a solution to a differential equation that looks like y double prime. That's a p of x there, and this is a q of x here. And they say if I can find a y2 with y1 prime, y2, oops, y1, y2 prime minus y1 prime, y2 is some constant k e to the minus p of x, where p is the integral of little p, then my equation y2 will also solve the differential equation. You guys with me on this? So this is just a method to take one solution and turn it into a second linearly independent one.
It's just the Wronskian, right?
Yeah, so this is just the Wronskian equals to some constant k times e to the minus p of x, right? And I don't even really care what k is, so I'm just going to put 1. Oh, and I know what p of x is, because little p of x is minus 8. So this is going to be 8x. That's thinking minus p of x is minus the integral of minus 8 dx. So I think I got 8x. Cool.
And then that c was our k that we just turned into 1.
Yeah, and the constant of integration was the k that I just turned into 1 because I'm lazy. So then I know what y1 is. It's e to the minus, or e to the 4x, right? So if I take that and shove it in here, I got e to the 4x times y2 prime minus 4e to the 4x times y2 is apparently, or I need to be equal to e to the 8x. So that one.
We could divide by e to the 4x.
Good. Divide by e to the 4x, so you get y2 prime minus 4y2 is e to the 4x.
And that's just a non-homogeneous first order linear.
Yeah, and that's a first order linear differential equation that you could solve. Right? You'd make it homogeneous and solve, and then you can, and then use variation of parameters to finish it off. And if you did this, you would get
X e to the 4x.
x e to the 4x. Cool? Basically, for the reason that you would see the product rule in the same way we kind of saw the product rule when we just tried this thing and differentiated. You guys kind of with me on that? Do you want to see the rest of that, or can I trust that you guys can solve? Yeah?
Yeah.
Okay, cool. Good point. Let's have a quiz.